Imagine standing under a silent night sky. The stars look frozen, distant, unreachable. But hidden inside that darkness, just 18 light-years away, astronomers may have found one of the most exciting worlds in the search for life beyond Earth. A planet not too close to its star, not too far away. A planet sitting in the mysterious region scientists call the habitable zone, the place where temperatures could allow liquid water to exist on the surface. Its name is GJ251c, and even though it is far beyond the reach of any spacecraft we have today, in cosmic terms, this world is practically in our neighborhood. For decades, scientists have looked at the stars and asked one question above all others. Are we alone? Not in a philosophical way, not as science fiction, but as a real scientific investigation. Somewhere out there, around another star, could there be a rocky planet with oceans, clouds, weather, chemistry, and maybe even life? Now, a newly identified super-Earth is giving astronomers one of their most intriguing targets yet. But before we go any further, let's be clear. Scientists have not found aliens. They have not confirmed oceans. They have not confirmed an atmosphere. And they have not proven that this planet is truly habitable. What they have found is something almost as exciting. A nearby planet candidate with the right size range, the right location, and the right conditions to make it worth studying very closely. And the next generation of giant telescopes may finally be powerful enough to look for signs of what this planet is really like. This is the story of GJ251c, a possible new world hiding in plain sight, only 18 light-years from Earth. For most of human history, planets beyond our solar system were only an idea. People imagined them, philosophers debated them, science fiction writers filled them with oceans, forests, cities, and alien civilizations, but no one had actually confirmed that planets existed around other stars. Then, in the last few decades, everything changed. Astronomers began detecting exoplanets, planets orbiting stars beyond the Sun. At first, many of them were strange giants, massive worlds larger than Jupiter. Planets orbiting so close to their stars that their atmospheres were being blasted by heat. Places so extreme they seemed almost impossible. But as technology improved, scientists started finding smaller worlds, rocky worlds, super-Earths. Planets bigger than Earth, but smaller than Neptune. And some of them were found in the most important region of all, the habitable zone. The habitable zone does not mean a planet is automatically alive. It does not even mean the planet is comfortable. It simply means the planet receives the right amount of energy from its star, where under the right atmospheric conditions, liquid water could exist. Too close to the star and water may boil away. Too far from the star and water may freeze solid. But in the middle, there is a narrow possibility, a balance, a cosmic sweet spot. That is where GJ251c appears to orbit. GJ251c circles a small red dwarf star called Gliese 251. Red dwarfs are the most common stars in the galaxy. They are smaller, cooler, and dimmer than the Sun. Because they shine less intensely, their habitable zones are much closer in. A planet around a red dwarf does not need to be as far away as Earth is from the Sun to receive a similar amount of warmth. GJ251c completes an orbit around its star in roughly 54 days. That means a year on this planet may last less than 2 Earth months. But even though it orbits much closer to its star than Earth orbits the Sun, the star itself is much dimmer. So the planet may still sit in the region where liquid water could be possible. And that is what makes this discovery so powerful. Not because scientists found a second Earth, but because they found a planet close enough, interesting enough, and promising enough to become a future target in the search for life. So how did astronomers find it? They did not see the planet directly. There is no clear photograph of blue oceans, clouds, or continents. Instead, they detected its gravitational fingerprint. When a planet orbits a star, the star does not sit completely still. The planet's gravity gently tugs on it. This causes the star to wobble slightly. That wobble is tiny, extremely tiny. But modern instruments can detect it by measuring subtle changes in the star's light. As the star moves slightly toward Earth, its light shifts. As it moves slightly away, its light shifts again. This technique is called the radio velocity method. It is one of the most important tools in exoplanet science. For GJ251c, astronomers used powerful planet-hunting instruments, including the Habitable Zone Planet Finder and NED, along with years of archival observations. They were looking for patterns, rhythms, repeated signals hidden inside starlight, and eventually, the signal of a planet emerged, a super-Earth, about 4 times the mass of our planet, orbiting in the habitable zone, close enough to Earth that future telescopes may be able to study it in much greater detail. Now, the word super-Earth can sound misleading. It does not mean the planet is better than Earth. It does not mean it has forests, oceans, or life. It simply means the planet is more massive than Earth, but still smaller than ice giants like Neptune. GJ251c appears to have a minimum mass of just under 4 Earth masses. That places it in a category that could include rocky planets. But mass alone cannot tell us everything. A super-Earth could be rocky like our planet. It could have a thick atmosphere. It could be covered in ocean. It could be dry and barren. It could be more like a super-Venus, trapped under a crushing greenhouse atmosphere. Or it could be something we have never seen before. That is the great mystery of exoplanets. From far away, a world can look promising. But until we study its atmosphere, its orbit, its star, and its physical properties, we cannot know what kind of planet it truly is. And this is where the story becomes even more exciting. Because GJ251c may be close enough for the next generation of giant ground-based telescopes to investigate. Scientists are preparing for a future where 30-meter-class telescopes can directly study nearby rocky planets. These telescopes will be enormous. Their mirrors will collect far more light than today's observatories. With advanced instruments, they may be able to separate the faint glow of a planet from the overwhelming brightness of its star. That is incredibly difficult. Imagine trying to see a firefly next to a stadium spotlight from miles away. That is what direct imaging of small exoplanets is like. The star is bright, the planet is faint, the distance is enormous. But with the right technology, astronomers may begin to detect light from worlds like GJ251c, and if they can study that light, they may be able to search for clues inside the planet's atmosphere. Atmospheres are like fingerprints. When starlight passes through a planet's atmosphere, certain molecules absorb specific colors of light. By studying that light, scientists can look for gases such as water vapor, carbon dioxide, methane, and oxygen. None of these alone would prove life, but together, under the right conditions, they could help scientists understand whether a planet is truly habitable. This is why GJ251c matters. It is not just another distant dot in a catalog. It may become a real observational target. A planet close enough that future telescopes could begin asking deeper questions. Does it have an atmosphere? Is it rocky? Could liquid water exist there? Has its star stripped the planet bare? Or has the planet held on to the ingredients needed for habitability? These questions matter because red dwarf stars are complicated. They are small and long-lived. Some can burn for hundreds of billions or even trillions of years. That gives planets around them enormous amounts of time for chemistry and maybe biology to develop. But red dwarfs can also be active. They can release flares. They can blast nearby planets with radiation. And because their habitable zones are close in, planets there may be exposed to intense stellar activity. Some may lose their atmospheres. Some may become tidally locked, with one side always facing the star and the other side trapped in darkness. But even that does not automatically rule out habitability. A thick enough atmosphere could move heat around the planet. Winds could carry warmth from the day side to the night side. Clouds could reflect radiation. Oceans, if present, could help regulate temperature. The truth is, nature is far more creative than our assumptions. And every time we discover a new world, the universe reminds us that planets are more diverse than we ever imagined. There are worlds where it rains molten glass, worlds darker than coal, worlds hotter than stars, worlds with 2 suns, worlds with oceans thousands of kilometers deep, and now, perhaps, a nearby super-Earth quietly orbiting in the habitable zone of a red dwarf star. J251c does not answer the question of life beyond Earth, but it sharpens the question. It gives scientists a target, a place to look, a world close enough that future instruments may be able to test theories that once belonged only to imagination. And when you step back, the distance becomes astonishing. 18 light-years sounds far, and for humans it is. A beam of light traveling at 186,000 miles per second still takes 18 years to reach us from that star system. Our fastest spacecraft would take thousands of years to get there. But in the scale of the Milky Way, 18 light-years is nearby. Our galaxy is over 100,000 light-years wide. It contains hundreds of billions of stars. So a potentially interesting world within 18 light-years means something profound. It means the galaxy may not be empty of possibilities. It means worlds like this may be common. It means that even in our local stellar neighborhood, there are planets we are only now beginning to discover. And that raises a breathtaking possibility. If a promising super-Earth exists this close, how many more are waiting? How many worlds are hidden around quiet red stars? How many sit in the habitable zone? How many have atmospheres? How many have oceans? And how many have looked up at their own sky beneath their own alien sun, while Earth was just another faint point of light? This is why discoveries like GJ251c capture the imagination, because they are not just about one planet, they are about perspective. For centuries, Earth felt like the center of everything. Then we learned it was one planet orbiting one star. Then we learned the Sun was one star among billions. Then we learned the Milky Way was one galaxy among trillions. And now we are learning that planets themselves may be everywhere. The universe is not just filled with stars, it is filled with worlds. Some dead, some violent, some frozen, some burning, and perhaps somewhere, some alive. GJ251c is not proof that life exists beyond Earth, but it is a reminder that the search is no longer abstract. We are no longer simply wondering whether other worlds exist. We are finding them, measuring them, naming them, and preparing to study their atmospheres. The next great discovery may not come from a radio signal. It may not come from a flying saucer. It may come from a faint pattern of light, a chemical signature, a tiny clue in the atmosphere of a planet orbiting a dim red star. Maybe oxygen and methane existing together in a way that demands explanation. Maybe water vapor, maybe carbon dioxide, maybe something unexpected, something that makes scientists pause, something that forces humanity to ask again, are we looking at an empty world? Or the first sign that life is not unique to Earth. That is the power of GJ251c. It gives us a destination for our curiosity, a nearby mystery, a world that future telescopes may help reveal. And perhaps one day, when giant observatories turn their mirrors toward this small star in the constellation Gemini, the light from GJ251c will carry a message, not in words, not in radio signals, but in chemistry, in color, in the fingerprint of an atmosphere wrapped around a distant world. And if that day comes, humanity may finally take one of the biggest steps in scientific history. Not by traveling to another planet, but by understanding one from across the darkness. So tonight, when you look up at the sky, remember this. Somewhere out there, only 18 light-years away, a super-Earth is circling a dim red star. Silent, distant, unknown. It may be barren, it may be hostile, it may be nothing like Earth, but it is real enough to make scientists look closer. And sometimes, that is how the greatest discoveries begin. Not with certainty, but with a signal, a wobble in starlight, a hidden planet, a question too powerful to ignore. Because every new world we find brings us closer to answering the oldest question humanity has ever asked. Are we alone in the universe? And maybe, just maybe, the answer is waiting in the light of a nearby star. Thanks for watching Infinite Science. If this discovery made you look at the night sky differently, make sure to subscribe, because the next breakthrough in the search for alien worlds could happen sooner than we think. The universe is vast, the silence is deep, but somewhere in that silence, another world may be waiting to be understood. And when science finally finds the answer, it could change everything.